Okay, so welcome again. This is third lecture of our comparative anatomy of integumentary system. So we were discussing scales. We have already discussed about the placoid scale. Now rest of the scale in fishes we are going to discuss in this lecture. Okay, so we already discussed about placoid scale, and this scale was found in Chondrichthyes. One of the most peculiar feature of this scale is that this scale versus the epidermis. Okay, it bursts the epidermis and protrudes out of it. But in case of advanced fishes, like now we are going to discuss about the scales of Osteichthyes. That means the scales here are going to be made up of bones because they are bony fishes, right? And in case of cartilaginous fishes, so the scales are going to be formed from the cartilage. Okay, we always study about things from simpler to the complex form. So this was the simpler scale, the placoid scale, and now coming to the advanced scale. These advanced scale in Osteichthyes, they are believed to be derived from the bony armor of primitive fishes, the class Placodermi. As I've already told you about this class, Placodermi, they are dead fishes. Only fossils are present. Rest of the scales in bony fishes are believed to be derived from the bony armor of these primitive fishes. So I've already told you the type of the scale that is found in this placodermi. So the scale was Cosmer scale, and let's just see a rough structure of Cosmer scale, like how it how it looks like morphologically. And in the Osteichthyes, when we'll come into the Osteichthyes, they are going to have scales like canoid scale, and cycloid, cycloid scale, and third one is ctenoid scale. Let's just assume like they are going to have four layers. Okay, let's just assume this is the scale. The outermost part of the scale is enamel, and inner to enamel is your dentine, and then you had pulp cavity. Just assume that this is your Cosmer scale and we are taking this much part of the scale and viewing the morphology of this microscopic part. Okay, so the lowermost part of the scale contains a very compact bony part that is called lamellar bone. Because they are bony fishes, so the hard part of the scale is going to be formed from the bones. So this is your lamellar bone, and above this lamellar bone is your soft bone. This is called your vascular bone. So these two layers makes the bony part of scale. Now you have here the dentine part. This is your dentine, and in the outermost you are having this enamel. These dentine and enamel are actually the term. These two terms are basically used for the chemical composition of your tooth. So in case of scale, this enamel is going to be called by another name called canoin, and this dentine part is going to be called by another name called cosmine. The term here used is different because they are chemically different, like chemical composition of this enamel and dentine is different from that of tooth. So this ganoin is actually a powdery substance which actually provide a shining surface to the scale. So that's why they are not called enamel but ganoin. So this is your Cosmer scale. This is the morphology of your Cosmer scale. And rest of the scale, when we see in the advanced fishes, these layers, they are going to disappear one by one. For example, in case of Ganoid scale, we are going to see that dentine is going to get disappear. The fishes that are going to have Ganoid scale, they are going to lack the dentine part of the scale. And in case of cycloid and ctenoid, they are going to have only the lamellar bone, and rest of the three layers, that is enamel, dentine, and the vascular bone, they are going to get disappear in these classes. So as we see from primitive to the advanced fishes, we are losing these layer one by one. Okay, so ganoid scales, they are very shiny scales. As I've already told you about the layer, like this is enamel, and enamel is kind of very thin, and then there is no dentine layer, and we are directly having these vascular bone, and then the compact lamellar bone. Okay, this is basically your ganoid scale, and due to this enamel, or this enamel here is called ganoin, which is actually a powdery substance which provides shining to the surface of the scales. So the example of the example of the fishes that are going to have this ganoid scale are, the first one is like polypterus, because they are going to have these ganoid scale in their whole body. And talking of the amia fish, they're going to have this ganoid scale only in the head region. And talking of the sturgeons, they're going to have this ganoid scale in their tail region. So these fishes are going to have this scale in different regions. So this was your ganoid scale, and now in more advanced fishes, these enamel, dentine, and lamellar, these three layer of these scales are going to get disappear. Only the lamellar bone will be present. Okay, so rest of the advanced fishes, and they are going to have two types of scale, that is called cycloid scale and ctenoid. I've already told you that they are going to have only this lamellar bone in their scale. Okay, below this is their like collagen connective tissue present here, and this lamellar bone is directly connected to this collagen connective tissue, and depending upon the type of connection these both the lamellar bone and this collagen fibers are having, they're going to make different shapes. Okay, in case of cycloid scale, you're going to see this concentric ring of this lamellar bone connected to the collagen fiber below. So this is basically your cycloid scale. In case of ctenoid scale, you are going to see two regions of the scale. The distal end is going to have this tiny spine-like calcareous structure. Okay, so this is your distal end, and in the proximal part, they are going to bear this finger-like projections. Okay, and these projections are actually scalloped. They are going to bear these rings of lamellar bone in the edges. So this is basically your ctenoid scale. So all the teleosed fishes, they're going to have these two types of scale. Okay, so this completes your scale in fishes. Fishes. Thank you.